Alright, hello CS141, and in honor of today's cold snow day,
I don't care what they're going to say. Let the storm rage on. The cold never bothered me anyway.
yes, from Disney's Frozen. I don't know if you've seen it. It's a fantastic movie, although I should mention that even though the character singing there says that the cold never bothered her anyway, that's because she has superpowers and can generate snow with their fingertips. The cold will bother you because it's minus 15 with a minus 40 wind chill, so please dress appropriately in layers and wear a hat and scarf and gloves and everything, and make sure you don't get frostbite. So there's no class today due to the cold snow day. Instead, I'm going to record what we would have done in class today and send that out to you. I'm not going to have review questions on Moodle or anything to answer, so you're just going to have to go through these clicker questions and kind of like guess at one of the answers, pause the video, and then go on and check out the explanation. I hope we don't have to record this part of things often, but because it's a snow day, that's kind of what we're going to be doing. We have to get to lab on Thursday. There's 2 different lab sections. There's over 40 people in the class. It's very, very hard to reschedule, so I want to make sure we get as much material covered as possible to make sure we're ready for lab on Thursday. Okay, so which of these are legal Java identifiers? Go ahead and take a guess. Did you come up with none of the above? If so, you're correct. Obviously, 5int is not a legal identifier. Remember, an identifier has to start with an upper or lowercase letter or an underscore and then be followed by 0 or more letters, digits, or underscores. So you can have digits in there, but not in the first position. So clearly this isn't right. Clearly this is wrong because it's got a space in it, and that's just not allowed. This looks like a legal identifier, int, but if you remember, int is what we use if we want to create a new integer variable. It would say like int x or int z or something like that. So this is not a legal identifier because it's what's called a reserved word or a keyword. It's a word that already has a special meaning in Java, and so you're not allowed to name variables something that already means something in Java. So none of these are actually legal identifiers. Is this legal Java syntax? Go ahead and take a guess, yes or no. Turns out, no, this is not legal syntax. This is legal, int x equal 5. This creates a new integer variable x, assigns it to value 5. This prints it out, that's fine. This tries to create another new integer variable also named x, and it's doing it in what's called the same scope. We'll learn more about scoping later, basically within the same set of brackets. Right now we're just going to have one scope, everything's kind of in main. We'll talk more about that later in the term. But the problem here, you've got this integer variable x you've already created. Now you're trying to create another one with the same name. That's not allowed, and so this is not legal syntax. How about this? Is this legal syntax? Slight change. What do you think on this one? So this is legal. This creates an integer variable named x and assigns it the value 5 and then prints it. Now it reassigns that same integer variable x with a new value of 7. This is completely legal, totally fine. And the key difference here we've got the creation of a new integer variable. Here we're taking an existing variable and we're reassigning it a new value, so we're just reusing something that was already created. That is totally legal. So how about this? Is this legal syntax? We've got this double D and we're assigning it an integer variable 100. Is that legal, yes or no? Yes, that's actually fine. Doubles have more precision than integers, so it'll take this integer 100 and it'll convert it to a double by adding, 100.0. This is usually called type conversion or typically type promotion because we're promoting from something with less precision to something with more precision. How about this? Will this work? We've got integer x and we're assigning it the double 0.0. Is that going to work, yes or no? No, this is not going to work. This is not legal syntax. These types are incompatible. You can't assign a double into an integer because Java will not do that conversion for fear of loss of precision. And so what that means is it's worried about rounding. So we're never going to round automatically. Now a human can look at this and say, well, 0.0, well, there's no rounding. You just convert that to 0. That's fine that a human can see that, but the computer's not going to be able to figure that out. So you're just kind of stuck with this not working. So how about this? We're converting Fahrenheit temperatures to Celsius temperatures. What is this going to print? So go ahead and try to figure that out. Did you come up with 0 or possibly 0.0? If so, you're correct. The reason being, this formula is correct algebraically, but remember, 5 divided by 9, well, those are both integers, so clearly you must have meant 0. Because 9 goes into 5 0 times with some remainder, but who cares? Those are both integers, so integer inputs, clearly you wanted an integer output. So this will be 0. You multiply the whole thing together, you get back 0. This is a pain for when you're starting out, because you're just not used to that. I often call it bizarro world. You're kind of stuck in bizarro world now, where 5 divided by 9 is not 5 nines. It's, of course, 0. So suppose we wanted to fix this. Which of these formulas would fix it? So go ahead and take a guess. Turns out it's D, all of the above. The reason being, obviously 5.0 divided by 9.0, these are both doubles. So if you divide two doubles, you're going to get back a double, so that'll work. But it turns out that 5.0 divided by 9 and 5 divided by 9.0, well, those are both one double and one integer trying to do division. Java's going to look at that and say, well, I can always take the integer and promote it to a double and then do the division. So all three of these actually, in practice, will mean the same thing. So now, this is a little bit more of an abstract problem. We're going to talk about what's called mirroring or inverting. This will make sense because we use it extensively in Lab 2 and Lab 5. Lab 2 is actually what we're going to do on Thursday. So suppose you have 10 doors labeled from 0 to 9 with cats inside them, and the cats are named 0 to 9 as well. I don't know why you'd name a cat 0, but let's just suppose that you did. So you've got a situation like this. You've got these 9 different doors, and then inside them you've got 9 different cats. Now here's what we want to do. We want to take this situation up here, where the cats are behind the doors that match their numbers, and we want to invert things so that, cat 0 goes over here to door 9, and cat 1 goes up here to door 8, and then cat 9 comes way back down here to door 0. So we want to figure out a formula where if I give you the cat's original door number, you can tell us what the door number that cat should go to. So let's assume that each cat stores their current door in a variable named I, which is an integer variable. What formula is going to tell us which door each cat should switch to? So here's your 4 possibilities, or none of the above. I'll give you a chance to think about that. And what's your answer? So it turns out it's going to be C, 10 minus I minus 1. And if you just plug in different values of I, you can see that this works. This is a classic formula for what's called mirroring if you want to figure out how to flip things. So if you want to, 0 goes down here to position 9, and 1 goes down here to position 8. Meanwhile, 9 comes down here to position 0, and so on. You're kind of mirroring everything about this point here. This is the formula, 10 minus I minus 1. And we're going to use this heavily in Lab 2 and Lab 5. Now, let's make this a little bit more general. Suppose we don't know how many doors there are. We just know that there's n doors. And then we know, once again, I, which is the current door that we're looking at. So what do we do with this formula? I'll give you a hint. It looks very similar to the last one. So it's going to be n minus I minus 1. And we're going to use this a lot in Lab 2 and Lab 5. So if we don't know how many doors there are, but we know that there's n of them, well, n minus I minus 1 will tell us where somebody behind door number I needs to switch to. And this is going to be, really, really useful for flipping things. Okay. Thank you. Please stay warm in the cold.